Hello, everyone. My name is Kristen Vandewaal, and I am the Product and Marketing Manager for Hendrix Overhead Solutions. I will be your host for today's webinar titled Hendrix Aerial Spacer Cable vs. Tree Wire vs. Bare Wire. This is the second webinar in our four-part series we're conducting between now and the end of June. You may have heard the cable terms tree wire, insulated wire, and Hendrix spacer wire. Although commonly thought of as synonymous products, each has its own distinct composition and best use applications. This webinar will cover the differences, advantages, and disadvantages of each in their niche applications. As for today's format, we will begin with a 45-minute PowerPoint presentation, and we'll follow that with another 45 minutes of Q&A for a total of 90 minutes. Many of you are already familiar with the Q&A tab located at the bottom of your screen. During the presentation, please use this tab to submit your questions. I will be screening the questions as they come in, and will relay some of them to our presenter during the presentation. Then, as time allows, we will address all other questions during the Q&A segment. Anyone who submits a question that we do not have a chance to get to will receive a response in writing from us. Now, I'd like to introduce you to today's presenter, Mr. Brian Traeger. Brian is a senior member of the IEEE. He received his Bachelor of Science and Masters of Engineering degrees in Electric Power Engineering from Rensselaer Polytechnic Institute in New York in 1979 and 1980 respectively, and a master's degree in business administration from the University of Pittsburgh in 1986. Mr. Traeger has held various positions in engineering, consulting, and management at American Electric Power Company, Cooper Power Systems and Fisher Pierce, as well as Hendrix Wire and Cable, where he has been for the past 26 years. He has taught electric power engineering at Ohio State University, West Virginia University, and Pennsylvania State University, in addition to teaching courses to utility clients. He has authored over 50 technical papers and articles for the IEEE and other national and international organizations. He has brought to fruition numerous high reliability power distribution projects in various sites on all 7 continents over a period spanning more than 40 years. Now, I'd like to turn things over to you, Brian. Brian, I think you may be on mute still.
Okay, sorry for that false start. Thank you, Kristen, for that gracious introduction, and thank you, attendees and participants, for taking time out of your busy schedule to join us here today for the second in our spring webinar series. Today, we're going to be talking about spacer cable versus tree wire versus bare wire. So without further ado, I'll get into that. Okay, the quick outline is that we're going to do an intro. Can't start without an intro, right? We're going to talk about definitions. What is bare wire, tree wire, spacer cable, so that we're all on the same page. We'll just throw in a couple of slides on theory of operation, and then we're going to get into the comparisons, basically the meat and potatoes of this webinar. And we're going to compare bare wire, tree wire, and spacer cable for costing, maintenance, tree wire, tree trimming, configurations, construction, the quality of service issues, both voltage regulation and reliability. We'll talk about some of the construction challenges, some of the construction benefits, and then the other categories like wildfire mitigation, harsh weather performance, and environmental stewardship, how our lines, or these various lines, react to bird and animal contact. So here's my one intro slide. Hendrix has been around since 1951. We've got 70 years in this business. We've got 15, 25, 35, 46, 69 kV. We went into 69 kV in 1995, so we've got over 26 years with that. We installed 115 kV about 18 months ago. That's still in pilot. We check it every couple of months for PD, do lab tests. It looks fantastic. And I guess we'll be going up from 115, so we'll see what happens there. Again, we're on all 7 continents, over 75 countries. We have continuous development in our engineering department, which leads to obviously continuous improvement. We're installed for reliability, economics, and safety. And as I always say, we don't recommend you using tree wire or spacer cable everywhere. It is simply a design option, one more tool in your kit as designers. People always ask, well, can I use it? What standards really cover spacer cable? We got National Electric Safety Code Rule 230D said covered conductors shall be considered bare conductors for all clearance requirements, except that between the spaced conductors. So we can basically bring those phase conductors closer together, and we can bring the circuits closer together. So that's a massive benefit. CSA just recently addressed it as recently as last year. They've been working on it a long time, and they said basically covered conductors swing in the wind more than bare conductors due to the larger surface area, but are protected from brush contact with vegetation, and therefore reduced clearances should be permitted. So Canadians took a long time to write this into their standard, but to their defense, they're doing a really good job because they're really taking a hard look at it, clearances and all these types of things. So I kudos there. This is not the last standard, but the last standard I'm going to discuss is ICEAS 121.733. And this is the ICEA standard for what they call tree wire and messenger supported spacer cable. So it applies to the materials, constructions, and testing of that covered conductor. And they don't say covered conductor, they say tree wire and messenger supported cable, which is fine. It doesn't address, the accessories. So, and it covers both thermoplastic and cross-linked polyethylene, whether rated for 75 or 90 C normal op temp service temperature. And one brilliant thing that the ICEA standard threw in, they added a cautionary note to ensure dielectric compatibility in selecting the components, which is basically a polite way of saying, don't use the wrong stuff. Don't use components that are dielectrically incompatible. Don't use components that are going to hurt your cable. Don't use porcelain insulators. Don't use blind posts with metal heads. So that's pretty good there. So we'll talk about bare wire systems, the purpose of the covering. So in bare wire systems, we're using air for the insulation. It's a halfway decent insulation, but we need a whole bunch of it. So therefore, you need a large separation between those phase conductors to prevent flashovers and to prevent face-to-face contact, conductor clashing, conductor slap. However, it's still subject to outages due to contact with trees and with animals. With covered conductors, what we do now is we put a little bit of polyethylene on those bare wires. That polyethylene is a great dielectric. It replaces most of the air, allowing closer spacing. That poly also provides a high impulse strength. It provides a high 60 Hertz withstand. And it will allow that cable now to withstand short-term phase-to-phase contact or for phase-to-ground contact without faulting. And that's a conservative statement on my part. It can withstand intermittent contact with trees and tree branches for the useful service life of that conductor. As far as sitting it on a dead short circuit, we have lab tests and we published this with the IEEE that it can sit on a dead short circuit for a full year. And I don't recommend that being done, but that's how resilient this system is. And briefly, what are the design objectives? Back in the day, we were trying to think, well, how thick should that insulation wall be? So we kind of decided, well, we'll keep it down to 350 microamps at 15 kV class. So that's 1/3 of a milliamp. What is that 1/3 of a milliamp going to do for us? It's going to allow us momentary contact without an outage. We know we're not going to trip fuses, breakers, relays, anything. And again, control of surface charging current is the key to virtually everything. It's going to prevent tracking. It's going to minimize safety issues. And when I say that, again, a live conductor is never safe. But if you touch that and you're, standing in a puddle and it's raining and you're wearing a copper overcoat and you've got copper shoes on, you're going to get 1/3 of a milliamp. And that's in comparison to 7, 10, or 19 milliamps that you need to fibrillate, in which case you can't let go. So yes, you're going to get a shock, and yes, you're going to let go very quickly. So is it safe? No. Is it fatal? No. The last thing is that we want to maintain insulation integrity over the useful service life. So we want that cable to last 40, 50, 60, 70 years. And that's what that cable design will allow us to do. The construction is that we use what we call a 3-layer construction. The first layer is a conductor shield, a semicon shield, and we're using a semicon shield for the same reason that we use a semicon shield in underground cable. What we do is we fill in the interstices between those individual strands with a semicon, and we fill the rough parts on the outside of those individual strands with that semicon. So if I get a dead short circuit, I get a utility pole that's metallic, fall down and touch that conductor, I got a dead ground on the outside of that jacket, and I have a high electric stress across that insulation wall. That semicon is going to smooth out the electric field, smooth out the stress, smooth out the voltage gradient, and minimize the partial discharge. So that will give us, again, a higher useful service life. It also enhances the BIL, and we discovered that through testing, if you will. The inner dielectric, you can see it looks white there. It's actually see-through. It's translucent. If you shine a light on it, that light will shine right through. And there's a couple of neat things about that. We use it's a high molecular weight polyethylene. We use a very low density, and that low density is so that we can stick a spiral stripping knife on the outside of that jacket, penetrate the outer jacket, and go, through more than half of the inner jacket and strip in a spiral fashion. So that smooth, low density inner jacket is really going to help stripability. The outer jacket, lastly, is where we put most of the tricks. First, we use a high density polyethylene, and the highest high density polyethylene we can source. And that's going to give us high abrasion resistance, and with the anticipation that at some point this is going to touch a tree and we don't want it to abrade. It's going to be also where we put our track resistance adder. It's going to be where we put the UV inhibitor, and that UV inhibitor is a chemical inhibitor, and that places a chemical umbrella on the molecular chains, the polyethylene chains, to protect them from the sun. It's not carbon black, it's not fugitive, so it will not break down over time. And lastly, in that outer jacket is where we put the color. You can have black or gray, and we can discuss that later if anybody's interested. We usually use black through the trees. Black looks good. Black is the favor of environmentalists. And we use gray when there are no trees and for the larger KV classes. And as you can imagine, if our design goal is to limit the charging current on the outer surface of that cable, due to Ohm's law, when we have a higher voltage, we need more resistance, right? So what we do is you increase the thickness as the KV class goes up. So you can see with 15 KV, you've got 2 layers there, 75 and 75 mils, give you 150 mils, or about 3.8 millimeters. Total insulation thickness. At 69 kV, we're using 250 plus 250, 500 mils, 1/2 inch thickness of that jacket, which is about 12.5 millimeters. So let's get right into definitions. I'm sure most of you know what bare wire is, but we'll suffer through that for a second. A bare wire, there we go. We're usually using ACSR, AAAC, sometimes AAC. Usually cross arms, sometimes it's armless. We're using the short brackets, maybe a ridge pin for the center. Normally pin type insulators, you can use line posts. It's simple, it's low cost, it's client accepted, linemen know how to install it, everybody loves it. You know, it's a solution for a good part of our utility life, but it's subject to outages from trees, wildlife, and conductor clashing. So this is what we're trying to solve here. Well, tree wire now, what we're doing is we're using, instead of that bare wire, we're using a heavily covered conductor that utilizes the 3-layer cable design we just discussed. Construction, we're using standard cross arms, or we can use shortened cross arms. You don't need the 6'9", 10-foot cross arms. You can use cross arms half that size, because if we have conductor clashing, it doesn't matter. We're not going to have an outage. We're not going to have damage. Or what is quite common in some jurisdictions, they'll use the shorter armless brackets, which are quite nice. And then we have the option to use either polyethylene pin type insulators or line post insulators. And that's what it looks like on a cross arm. I should have shown it armless, and hopefully I will next time. Spacer cable. So here we go. We've got heavily covered, non-shielded phase conductors held together and supported by a high-strength messenger. Now you can see the messenger up here. You see the heavily covered conductors. The messenger on top, it has 3 or 4 functions. The first function is that it's the mechanical support member. It's basically holding everything up in the air, and it has other functions. It's a lightning shield wire. It can be your system neutral, and it also has a mechanical function that it serves to physically protect the phase conductors beneath it, because when something falls on that bundle from a top, whether that be a tree or a tree branch, that fallen object won't hit those phase conductors. It will sit on the messenger. So it's a mechanical protector as well. We've got a spacer. You can see the spacer is at the pole. It's just at the pole because we have a transformer tap, but the spacer can be anywhere. And we have one of those every 30 feet. And the spacer is you know, just a humble insulator. It's basically you put all 3 phase conductors and you hang it up there on the messenger. It's the same as taking a hanger in your closet, putting a shirt on it, and hanging it on the pole. So it's not more complicated than that. And those phase conductors are non-tension. They're only holding up their own weight. So we don't have a lot of mechanical requirements on that spacer. What else? We got a couple of brackets. You can see we've got a tangent bracket there. We've got angle brackets, a couple of those, dead end bracket, and that's it. It's a very simple system. I wanted to take a moment to say, yeah, we also have a single phase spacer cable, and that's used in a lot of, say, backlot construction, where they decided in the 50s that they didn't want to have power lines out in front of the house, so they would put power lines between the houses down the back alley, which seemed to be a good idea at the time, but it was an absolute disaster from a long-term maintenance, but that's another subject. We also have a lot of single phase out through the roadway. Okay, so we have our theory and construction down. Now we'll start talking about our comparisons. The first 2 will be cable construction and mechanical configuration. For the conductor, bare wire, yeah, we'll use an ACSR, triple AC, sometimes double AC for the larger sizes. Tree wire, usually ACSR, triple AC, sometimes double AC for the larger size, same thing. With spacer cable, we almost always use double AC. It's lighter, smaller diameter. We can compact it, which means when we compact it, we get a smaller diameter and gives us the opportunity to use less polyethylene, which is expensive. Because it's smaller, it has a smaller physical profile, which gives us less wind and ice loading, which is good for our poles, our guys, what have you. We've also got higher ampacity and a lower cost. When we compare the construction with respect to insulation, well, obviously bare wire has no insulation, but the difference between tree wire and spacer cable with insulation design is 0. The same exact layers, the same exact thicknesses, the same exact materials, and the same exact objectives. I thought it would be helpful to throw in a couple of caveats here is when we use tree wire, we can also use AAC. So with the larger sizes, we're going to have that higher rated tensile strength that will allow us to build long spans or longer spans or wind, ice, etc. And the other caveat for spacer cable is even though we always use AAC, it is possible to use ACSR or AAAC. Again, it's mechanically viable, not economical, not beneficial from an ampacity standpoint, but it may be beneficial from a stocking standpoint. One or two clients we have to stock ACSR so that when the crews are rolling, one day they're installing tree wire, so they bring out the ACSR. The next day they're installing spacer cable, and they just use ACSR. So it's, you know, that's a Benny from an SKU standpoint. Mechanically, right. So attachment to the pole, obviously bare wire, cross arm. Tree wire, I can use a cross arm or a smaller cross arm or a compact bracket. Spacer cable, I'm always using a compact bracket. When we talk about dead ends, bare wire obviously is fully tensioned, so we need full tension clamps. Tree wire, similarly, fully tensioned, so we need full tension shoes. With spacer cable, it's only minimally tension. There is no tension. It might be 100 pounds. For really heavy conductor on the worst day of the year, it might be 400 pounds. So we're using partial tensioned preform grips. And the Benny is that those preform grips go over the outer covering of that spacer cable jacket. We never have to strip. So I put in, instead of caveats, I said dead end comments. With bare wire, there are none. With tree wire, the bummer there is that we require stripping because you can't put a full tension clamp on top of the insulation. So you've got to strip that. So you begin to lose some of the benefits of the covered system. Some of our clients on the West Coast that started using tree wire have gone through a lot of trouble. They know they have to strip it. They know they're using full tension clamps, but they're covering up where they stripped. So with kind of like wildlife protection products, so that they're doing a good job out there. With spacer cable, there are no comments. The system remains covered everywhere. There's no stripping required. When we talk about physical profile, bare wire obviously requires more right-of-way, and it is exposed to fauna and flora. Tree wire, well, we don't have a messenger to protect those phase conductors. We don't have that mechanical protection. So there's only so much compaction can be achieved. And it's also vulnerable to overhead trees. When we talk about spacer cable, it's always compact. And those phase conductors are always protected by the messenger. Let's go into a little bit about tree trimming and maintenance. These are specs we got from a local utility, the largest utility in our New England area here. I won't identify them, but on the left you see routine maintenance tree work. So they go 15 feet above the utility equipment, 10 feet below, and 8 feet to the side. You can see that tree's not too happy. We have what we call enhanced tree work, where the specs are 8 feet from electrical equipment for the ground up. Tall trees growing under the wires will be removed. And then we have what we call routine maintenance tree work. So here we go 20 feet above the utility equipment and 8 feet to the side. Now, other utilities may have less, other utilities may have more. But you kind of getting the idea here that these trees are not happy, and neither the people that live on this right of way. So when we talk about tree trimming for bare wire lines, in many ways, extreme measures are sometimes required to meet the utility specs and save that tree. But it's going to result in a loss of aesthetics, and that tree is still at risk of contacting the power line and causing an outage. And again, everybody's seen these extreme methods that they go through to save these trees. The trees look hideous afterwards. But I guess folks are satisfied, not sure. If we take a look on the left here, now you can imagine on the left, we've got either bare wire or tree wire, which requires the same amount of trimming as bare wire, by the way. If you take a look on the left, that might be 7, 8, 10 feet, whatever the spec is. And then to the sky above those tree wire or bare wire conductors. Now, if you take a look to the right with spacer cable, what we've done is we've removed that cross arm. We've put a compact bracket on the street side rather than the load side. And now we're saving, 6, 9, 12 feet of that tree on the side. And as far as the top of those phase conductors, you really don't have to remove those tree limbs, because if they get wet, they're going to come down. They'll sit on the messenger. That messenger can handle it mechanically. It has a very high rated tensile strength, and the messenger can handle it electrically because it's grounded every pole or every second pole or every third pole. So it's a completely different deal. So if we look on the left, you got conventional bare wire or tree wire, and you're massacring trees. If you take a look on the right, this is a photo from a utility that is in a jurisdiction that prohibits tree trimming. So what they do is they just have to build their power lines through little tunnels in the trees. And this is quite common in many areas of the US and other countries as well. So tree trimming, we just discussed that. Tree wire requires more patrolling, since when large limbs line across phases won't cause outage, they'll eventually cause abrasion. So bare wire uses full attention, short tree trim cycles to keep the lines from the foliage, still at risk. Tree wire, while intermittent contact is okay, you got to take a look, you got to worry about those large branches above. Spacer cable, you're saving 80% of the canopy, you're saving 80% reduction in tree trimming. Intermittent contact is okay, and you got to maintain your clearances. Maintenance, this is I guess debatable. This is my summary. Maintenance with bare wire is periodic. You got a trouble with bare wire, it's easier to spot, right? Tree wire, we recommend annual maintenance, annual patrols, and or after big storms. Again, worry about the trees lying across the top. Spacer cable is going to be the least maintenance, periodic, do annual patrols or after big storms. That maintenance will be minimal, and we recommend that you maintain an inventory.
Excuse me, Brian, we just have one question. Is there a specified vegetation clearance requirement with spacer cable?
That's a very good question. So the answer is that since National Electric Safety Code Rule 230D says you must maintain all clearances, and there's some caveats to that, which I'll get to later, with respect to trees and so forth. Yes, your clearances for spacer cable with respect to vegetation are going to be the same as with bare wire. However, if the power line is 9, 10, 11, 12 feet farther away from the tree, you're going to save 9, 10, 11, 12 feet of that tree. So that's where the savings are going to come in. If your spec says that you need to maintain 15 or 20 feet above the tree, above the power line, and cut all the tree limbs above, then obviously you are required to acquiesce to that specification. However, if you fly up here to the factory, I can take you around in my car for a couple of 1,000 miles and show you power lines where the trees are directly above the spacer cable line. So that answer probably didn't satisfy you that much, but that's how it goes. Okay, let's talk about costs. So we put this chart together, and it's only probably relevant for a couple of projects, but it's a good summary. If we take a look at material cost, we say we're going to compare it to bare wire, because that's what everybody asks. When we go to tree wire, we just put in poly on the polyethylene on those bare conductors. We're changing out those porcelain insulators for poly insulators. So it's a tiny bit more expensive, maybe 20% at 15 kV, 30% at 35 kV. When you look at spacer cable, those costs go up a little bit, the material costs, and they might be as much as 50% higher at 35 kV, 25% at 15 kV. If you look at the labor cost, we're saying, well, bare wire is 1x, right? Tree wire, pulling in tree wire as compared to bare wire, it's the same darn thing. Same techniques, same amount of time. I just gave you another 10% because somebody's got to strip those dead ends to put them in the dead end shoes. We talk about spacer cable. I want to say it's the same. I want to say it's less, but these are the numbers we've gotten from clients. So we're saying 10% premium in labor costs at 15 kV. It might be 15, 20, 25% when you get to the higher voltages. Tree trim, bare wire is 1x, tree wire is 1x, spacer cable, I have an error there. It should be 0.2x. I'm saving literally 80% of my tree trimming. Site prep, bare wire is 1x, tree wire is 1x, and spacer cable, I'm saying it's about half of that because you might not be moving poles, you might not be actually removing trees. We're going in with the original sites, with the original pole line. So it's in some cases it's the same. In some cases it's half or less. Maintenance, I'm saying bare wire is 1x, tree wire is 1x, and spacer cable is a little bit less than that. We're asked sometimes about, well, what are the differences with respect to energy savings and these types of things, leakage, carbon footprint. So with bare wire, obviously, there are no savings with losses and voltage regulation. With tree wire, we have the same GMD, right? We have the same spacing between phases. So voltage regulation, there's no change. With spacer cable, we've got lower losses due to the fact that the voltage is going to be properly regulated and the need for higher voltage at the head of the feeder is eliminated. How about leakage? Bare wire, there's no savings. Tree wire, there's lower losses since the conductors will not be releasing leakage current to the trees or insulators except at bare spots. And if we cover up those bare spots, even less. Spacer cable, it's the best scenario. Negligible leakage because there are no bare spots. Carbon footprint, we have numbers on, how many tons of carbon dioxide, carbon monoxide you save with trees. I didn't put those numbers in here since I barely understand them. I'm sure the other folks don't either. But carbon footprint for bare wire is obviously poor. When we talk about carbon footprint for tree wire, we're going to have more trees and foliage. And therefore, that's going to relate to cleaner air through absorption of carbon monoxide and other pollutants. When we get down to spacer cable, it's absolute best scenario because even more trees and even more foliage relates to cleaner air through absorption of carbon monoxide and other pollutants. And we've all seen construction projects where we go in and we build either bare wire or spacer cable, and the amount of trees removed for one project versus the other is just an enormous, mind-boggling. Bird and animal contact. We've got more photos than we could possibly show. I tried to show some non-insulting photos here. Bare wire is always vulnerable. We've got animal-related outages. We've got squirrels. We've got snakes. We've got birds. We've got the occasional climbing animal, whether it's a mountain lion. We've got dead raptors alighting on a cross arm, dropping down, spreading their wings between the energized phases of a bare conductor, and it's a very sad ending for that bird.
Excuse me, Brian. We do have one question that pertains to that slide. Is there an advantage to using spacer cable versus tree wire when it comes to avian interaction?
Yes, but not much. Okay, good question. I gotta write that one down. So, right, no, I would say they would both be fabulously bird compliant. The only caveat there is that with tree wire, I've got to strip the dead ends to put on my full tension dead end grips, my full tension dead end shoes. So if the bird, and again, we've seen our Western clients, they're really covering up those strip points, and that's really fantastic that they're doing that, because the Western utilities really did that before anybody else. So if you're covering up your strip points, there is absolutely no difference with avian protection between space cable and tree wire. And thank you for helping me out there. Okay, tree wire. What's the other difference? And this is historical. There's been a great tendency to use wrong components, and we've written IEEE papers and done research, for 70 years over what happens when you use the wrong components. And we're still doing this, in Europe or in South America and Asia. Over the years, folks use porcelain insulators and the wrong dead end shoes. It's too much stripping, and that led to problems. I think folks are finally beginning to understand dielectric incompatibility. You can't use porcelain insulators, et cetera, et cetera. So those are going away, as the questioner rightly pointed out. So to summarize, tree wire provides temporary fall protection. Birds, animals are mostly protected, and we've only got to look at the stripped dead ends to cover them up, because they will pose a safety hazard. When we look at spacer cable, it's completely covered system and it eliminates the safety hazards. It's applicant compliant, and it's ideal for we use it in national parks and wildlife areas and waterfowl and migration habitats, and we're using it in national parks in US, Canada, Mexico, all over South America, Europe, Asia, Australia, New Zealand. It's really well done. And we've got tons of photos, no stop of photos, but we've got photos with bald eagles sitting up on spacer cable poles. We've got monkeys on spacer cable poles. We got three-toed sloth on spacer cable. We've got anteaters. We've got all kinds of stuff. I got stuff, yeah, pretty neat. So we covered that slide. Let's talk briefly about harsh weather performance. Okay, how do bare wire systems do in harsh weather? Here's a quote I got from somewhere. It said, if not rigorously, quote unquote, storm hardened, it will not perform well in harsh weather. And depending upon where we are in this country, we've got ice storms or we've got hurricanes, we've got tornadoes, the whole deal. And a lot of that comes down on the ground. When we look at a harsh weather of tree wire, yeah, it's going to give us temporary fall protection. It's resilient to tree limbs. We're worried about the large branches above that may fall down. And, we're worried about pole breaks, but many of tree wires that the conductor is going to break before the pole. Spacer cable is more robust, extremely more robust in extreme weather due to the mechanics of the design. The overhead messenger is going to protect the phase conductors from the trees and branches, the stuff that's falling from overhead. If the line stays energized, and even if it hits the ground, there's going to have no outage. One possibility is a super large impact may cause a pole to break, and that's going to take longer to clean up. But still the power is not going to go out. And we're using spacer cable, we're using covered conductor for reliability to improve our safety and SAIDI indices. And what I didn't talk about environmental resilience. We have information out on contamination related applications. So where you cannot use bare wire, you're using tree wire and spacer cable. It's resilience to seacoast contamination, not simply in Massachusetts, that's just a pretty picture, but all over North and South America and Europe and Asia. Here's a cool photo I just had to throw in. We had a tornado here about 6 years ago on the north side of Boston, and everything came down. I mean, this is a tornado. I don't know, it just hits like 2 or 3 blocks. I don't know how that's possible, but everything came down. You can see the trees are down, but the spacer cable's still up. This is a photo I took out of the Boston Globe. This is Pepco 69 kV in Washington, DC. So they were doing a helicopter patrol, called in and said, you got a line down, transmission line down, 69 kV. They said, we don't have it down, send out crews to take a look. And they took a series of photos. These photos are on our website. So we don't know if this tree was on that line for 2 weeks or 6 months. We just know it was on the line. It didn't cause damage. There was no tracking. There was no anything. And that line staying energized. And if that came down, it would have taken everything down, including the underbuilds. This might be the best photo we have. This is the Northern Rockies, where winter is pretty long and winter is pretty serious. So this is Banff National Park in Alberta. And if you take a look, this is spring patrol, maintenance patrol. If you train your eyes, you can see in the back, you've got 1 tree, 2 trees, 3 trees sitting on that messenger. So I imagine they use pretty stout poles, but that's pretty darn impressive to have 3 trees down across your power line and not a flicker. So that line stayed energized, pretty neat. And there's a good photo. So here's a major client in Central America. They had a tree down, and this is on a single phase line. So that was pretty interesting. No outage, still in the air. And as we always say, we have spacer cable on all 7 continents. This is Antarctica. There's 1 medium voltage system on the whole continent, and this is it, McMurdo Bay. So you can go to the McMurdo Bay website on the web, and they have live cams. You can see this line, and they add a couple of sections every year, every other year. So this is operating quite well. Okay, so bare wire is prone to outages, lines knocked to ground, quick restoration time. Tree wire is good. The only negative is you may have branches lie across the phases and cause abrasion. Spacer cable has the highest resiliency possible. It's resistant to wind, ice, and hurricanes. There's a consortium, not a consortium, every utility in the British Isles, 3 countries, commissioned a study from a consulting firm, their consulting firm, EA Technologies. It's kind of like our EPRI, if you will. So EA Technologies, they did this study in 2000. They asked us to participate. So what those objectives were is they wanted to study bare wire versus tree wire versus spacer cable in extremely harsh weather. So they have a research center, a field center on the British-Scottish border, what they call Deadwater Fells at Hadrian's Wall. It's 1,900 feet elevation, and it's 50 miles east and west of the Northern Irish Sea. So as you're standing up at this site, you can look one way and see the North Sea, and the other way and see the Irish Sea. And there's some serious winter weather up here. And it's instrumented to fabulously temp, wind speed, direction, barometer, et cetera, et cetera, et cetera. They also have a lot of mechanical instrumentation on here to get the conductor tension and vibrations. They also had high-speed cameras. So this is a pretty large study, took a while. So this is effective wind on the conductors, wind only, no snow or ice. And they found that, oddly enough, that line on the top is the tree wire. And at this point, they were still calling it BLX because that's the Scandinavian term for tree wire, BLX. We use the same size for the 3 power lines. They found that tree wire is always affected worst by the wind because it has the largest size to weight ratio. They found that spacer cable always exhibits the lowest % increase in load, where bare wire was somewhere in the middle. Bare wire is pretty good. Bare wire is pretty close to spacer cable, but spacer cable was absolutely the best performance in harsh weather when we consider wind. Had several snowstorms that winter and ice, and they found that you can see the line on the top there that the tree wire was similarly always affected worst by snow and ice. And spacer cable was absolutely the best performer, the line on the bottom with the triangles. The black line in the middle, bare wire performs well, but not as well as spacer cable. And when this study was presented, it was presented at conference, and I took some words out of that. I did not have the ability to edit the study, but these are precisely the words out of the study. And it said, these graphs have tried to summarize the data in simple graphical form. However, looking at the data, generally, some conclusions can be drawn. Number one, the Hendrix spacer cable has performed extremely well in very severe conditions. It has had to withstand wind gusts of hurricane force, as well as severe snow and ice incidents. In comparison with single sheath covered conductor, tree wire, the Hendrix spacer cable has accreted less snow ice and suffered less from wind loads, especially as the weather conditions got worse. And lastly, in comparison with bare hazel, the Hendrix spacer cable has generally performed better under all scenarios. So this is a real great study, and they've got the data to back it up. Wanted to touch briefly on wildfire mitigation, which is the new system hardening, if you will. So what are the differences between bare wire, tree wire, and spacer cable with respect to wildfire mitigation? And we have to clarify here that we're not talking about wildfire survival, because there are techniques to survive wildfire, which we won't get into now. But we're talking about mitigating. We want to mitigate the risk of our power line actually igniting a wildfire. If you take a look on the left, we're using tree wire. And this is kind of ironic, but some of the Western utilities have said, well, we love spacer cable, but we're basically going to, most of our areas, we're going to use tree wire when there's no trees, because the concern is that we have a palm frond ignites, and apparently, and they've got videos of this, that palm frond can fly, ignited palm frond can fly 1 to 2 miles. But what's going to happen, the worry is that palm frond is going to get between 2 bare wires. That fire is ionic plasma. And if we put an ionic plasma between 2 bare wires, we're going to have a flashover. So again, that palm frond may land and cause a wildfire 2 miles away, but when the investigators get out there, the only thing they're going to see is that they had conductor clashing, a flashover, and the power line caused the wildfire. So this is something we want to avoid, okay? We're going to use spacer cable for wildfire mitigation. When we do have a lot of trees or any trees, we have reduced right-of-way applications, multiple circuits, and so forth. So bare wire, no mitigation. Tree wire, it's good when there's no trees. And spacer cable, intermittent tree contact is acceptable. If a line comes down and hits the ground, it's not going to throw a spark like a bare wire will, so there's no ignition. If there's a line down and it's energized, there's not enough current to start ignition. So it's a very viable wildfire mitigation strategy. Talk quickly about these last few items: right-of-way, spans, multiple circuits, and storm hardening. Reduce right-of-way when we got to go through an alleyway or something. Bare wire, the only alternative is to build it above the roof line, but you require, by National Electric Safety Code Rule 231, you need 12.5 feet above the roof line, which may or may not result in unreasonable pole heights, and has still resulted in electrocution of painters with steel poles on lead roofs. We've got issues, we got safety issues, and it's simply impossible with tall buildings. when you look at spacer cable or tree wire, we've got that revision to National Electric Safety Code, and it says the clearance can be reduced by 2 feet. Okay, so that's massive. So here we're doing this is a standard 5 to 15 or 25, 35 kV upgrade in a alleyway. So we already figured out, you know, we can't use bare wire because the poles will be too tall. We can use underground. We love underground cable, but we might have to do a lot of digging. There might be other utilities under their sewer or heavens knows what. I can't fit bare wire down the middle because there's no way in a 14-foot alley to get 7.5 feet on either side. National Electric Safety Code lets me reduce that by 2 feet. So I got 5.5 feet on one side, 5.5 on the other. I got perfect 3 feet to build that line. And this is a very common technique for commercial or if you go suburban alleyways. So you can see on the left what the linemen lovingly refer to as the rat's nest. And after the upgrade, on the right, just build it right down the middle. And we can also do that with tree wire. We have the same advantage for reduced right-of-way with tree wire. The problem is, you know, I've got more space between my phase conductors. I don't have that really, really compact bundle. Here's an interesting case. What they did is they had to have a substation exit with 3 circuits. The bare wire line went down the street maybe a half mile, 3 blocks over, a half mile back. So what they did is they just put 3 circuits on a pole, went down this alley, satisfied National Electric Safety Code, saved a small fortune. How about long spans? Bare wire, you know, spans greater than 500 feet, usually using 3 poles. Tree wire, yeah, we're going to use heavier poles, but we might be able to use 1 pole. And the benefits to bare wire compared to bare wire is because there's no conductor clashing. If I have conductor clashing, there's no outage. With spacer cable, I'm going to use 1 pole, not 3. All the mesh strength is in the mesh, there is no limit to the crossing length. And actually, the longer the crossing, the greater the benefit compared with tree wire or bare wire. And highway crossings are kind of a, you know, we're talking river crossings, mountain crossings, but highway crossings are kind of a standard in several states here in the north. We're beginning to see this out in the Midwest and Indiana, Ohio, and Texas. So this is pretty cool. This is a 600-foot crossing, double circuit 795. Here's White River in Indiana. They had 3 options, and this is 500. This is 1,600 and something feet. Obviously during construction, and the options were submarine cable, 1 million, build around the shoreline, 800,000, and spacer cable. They had to buy 2 stout poles and 1,600 feet worth of cable. So that was a massive, massive slam dunk savings. How about multiple circuits? When we talk about bare wire, we're usually limited to 2 circuits per pole. You can put more on there, but the lineman won't work it. Tree wire, there's theoretically no limit to the number of circuits per pole, but more than 2 circuits, it starts getting cumbersome, it starts getting crowded, and it's generally not used except in cases with over and under builds. Spacer cable, theoretically and practically, there's no limit to the number of circuits on a single pole. So we're doing transmission line underbuild, distribution line overbuild, substation exits. Here's a famous wind farm in Canada that was erroneously built with bare wire. Right, so first winter, this whole thing was on the ground. And this was about 10 or 12 years ago. I'm sure they're still in court settling that out because that was a mess. That was a mess to put together. Talking about spacer cable, multiple circuits, you know, there is no limit. We got 8 circuits on a pole with substation exit on the left. We've got, this is a solar ranch on the right, is 6 circuits of 1272 kc mil, 35 kV. no problem getting them on the pole. Here's another solar ranch that was built. We put 11 circuits. You can see it's 5 on a pole on the left, 6 on a pole on the right, and you can't see further back on this ranch. We've got 9 circuits on a pole. Put 50 megawatts on each. Now we're putting 60 megawatts. This is absolutely brilliant. We talk about multiple circuits we're doing here. We've got a 69 kV line on the top, 25 kV spacer cable line on the bottom. We're doing a lot of work with 69 kV in national forests, not only in the US and Chile, but Canada, and we're looking elsewhere, and also in the Caribbean, if you will. Reduced right away, bare wire is difficult at less, tree wire is better, spacer cable best, long spans. Bare wire, you need 3 poles, tree wire is better, spacer cable 1 pole, it's more compact, multiple circuits. Massively favors spacer cable. Storm hardening, bare wire is difficult. There are a few options. Again, we can use increased pole class, voltage circuit indicators, loop feed, smart grid, but that's about it. Tree wire, it's better than bare wire. The weak link is the conductor, insulator, and the pole. Spacer cable, with respect to storm hardening, is intrinsically hardened already. We've got multiple, and above and beyond that, we have multiple design options to increase the hardening. Use a heavier messenger, a heavier pole, combination, flex bracket, smart grid. So yeah, this is pretty valuable. Quality of service, bare wire, same configuration, same GMD, no reduction in mutual inductance, no improvement in voltage. Spacer cable, because we've brought those phase conductors together, the mutual inductance is almost canceled. The total impedance is reduced by 15 to 20%. We have a 15 to 20% better end of line voltage. So we're probably buying less aluminum or serving a 20% longer line. And we also have a better power factor. Restoration time. Tree wire, faster restoration time for faults involving pole failures, safety reliability concerns when conductor is exposed to long-term abrasion. Yeah, so pros and cons. Spacer cable for extremely large, heavy tree, result maybe a pole break. So this is, I guess, the Achilles heel. You may have a slower restoration time for spacer cable, but you're having, instead of having 10 faults in 10 years, you're having 1 fault in 20 years. You got to have something really serious hit that pole before that pole breaks. Reliability, bare wire. Bare wire, SAFE, SADI, CADI are inherently poor. Tree wire, SAFE, SADI, and CADI are inherently favorable because we're not having temporary faults. Spacer cable, it's good, better across the board. All the reliability indices are improved. We have reduced outages, reduced loss of revenue, reduced trouble crew and maintenance cost, and greater regulatory compliance and penalty avoidance. And I have here, what's the cost of reliability? And some of these are, obviously, we're not paying the Public Utility Commission penalties. It's better public relations. We're not having lost revenue. We're not sending crews out on Saturday night to find faults. We're not losing industrial load. We're attracting industry, and we have a lot of high reliability industries that are using spacer cable. Loss of critical loads, whether it's hospital or data center. And if you look at the federal government data centers and Amazon centers and Intel centers and these things, they are all spacer cable connected. This is relative, it's not exact. Bare wire, increased cost, increased reliability, and obviously tree wire, spacer cable, underground cable. Voltage regulation, again, bare wire and tree wire, no advantage. Spacer cable, 15 to 20% improvement. Bare wire depends on the adequacy of the surge protection, depends on the adequacy of their over voltage protection. Tree wire is potentially worse because I've got stripped dead ends. Now I got to figure out how to cover them properly or put lightning arresters on them. Spacer cable surge protection is excellent. I only need Arresters where I've stripped. Restoration time, bare wire is the fastest, okay? Tree wire similar to bare wire, and spacer cable is going to be longer than either of those. Reliability and associated cost, bare wire is inherently poor, tree wire is better, and spacer cable is extremely high. Just wanted to touch briefly before I hand it back to our moderator. We now have a tool that's called the value calculator. And what this is going to do is going to help you find the value. What is the value of going from bare wire to tree wire? What's the value of going to bare wire to spacer cable, or from tree wire to spacer cable? And so these are the things you want to know. Is there a value? So you get to enter the application, the location, the type of circuit, what your alternative is. You compare bare wire to spacer cable to tree wire, how long that circuit is, and the number of years you're using for the analysis. And it lets you compare, you say, well, the application is limited right of way, maybe the application is wildfire mitigation, maybe the application is multiple circuits or substation exit, maybe the application is trees, environmental. And it allows you to do all these comparisons, including underground. So you can set up a business case to present to your management that you would say, here's for bare wire, tree wire, spacer cable, and underground, and here's all the costs, and here's all the benefits. So that's brilliant. And it gives you the financial metrics that your management folks are going to want to see. The present value, the cost of delay per month, the cumulative benefit, the cost of not doing it, and all these other things. So you can get together with your local Hendrix rep or regional manager and discuss this. This is brilliant. Without finishing here, I just want to say that we've got two more webinars coming up in our spring series, and then 4 webinars coming up in our fall series. We thought we'd give you the summer off. But the next one coming up is going to be spacer cable installation. And this is one that's been asked for and we've never given. So it's a properly designed and installed Hendrix spacer cable system. This is going to be great. It's going to come from one of our installation specialists. So this is great. Have your ops people drop in on this one. Lastly, on June 24th, we'll do restoration and safety. And this is another one you want to get your ops people on here. So this is how to put it back together when things go bad. So that's pretty cool. And lastly, people want to get CEU credits for their PE boards for their requirements. If you contact our moderator, Kristen Vanderwall, she will send you a diploma or certificate of completion that you can use for submission for CEU credits. And I will turn it back to our moderator, Kristen Vanderwall, for if there are any questions. And thank you so much for your time.
Thank you very much, Brian, for that excellent presentation. We did have several questions that came through. The first one is, would using a 35 kV spacer, regardless of system voltage, would that give you allow easier access when crews are working with hotline tools?
Yes, yes, and yes. And we even have a bigger spacer than the 35 kV spacer. We have what's called the RTL G095. So instead of getting 12 inches between those phases, you're getting 18 inches between those phases. And we're using that in high contamination areas. We're using that in California, and Arizona, and New Mexico, and Nevada. So yes, some clients are using them so at equipment locations, cap banks and transformers and such, where they don't want to put a bracket, they just want to hang a spacer, but they want the folks, the linemen, to have a little more space between those phases to use hot stick tools. Next.
The next question is, what's the easiest way to remove or strip the covering on tree wire and spacer cable?
Good question. Okay, so we have in our catalog, we have a series of tools. There are 2 companies. One is called Ripley. The other one is called Speed Systems. They both have excellent tools. They have what we call fixed diameter tools. So you just close a barrel over the cable, and you have a knife and you strip in a spiral fashion. Then we have what's called variable diameter tools that are really fantastic. They can do different kV levels, different conductor sizes, but require a little bit of patience calibrating before that first strip or that first cut is made. So yeah, if you contact us, we'll put you in contact with where we have these tools on the shelf, but I think they're mostly variable OD. But if you contact us, we'll spec out a tool for you. Next.
Does covered wire provide better protection against lightning strikes?
Absolutely, positively, beyond the shadow of a doubt, because if we look at a system BIL, look at a system BIL. Let's talk simply at 15 kV. That cable in itself is going to give you somewhere between 200 and 250 kV BIL. Once we add in the spacer, we're up to 300, 350, 375 kV BIL. So yes, and if you look at a 15 kV BIL, you're either, for bare wire, you're either 95, or for high BIL, it's 125. So you fantastic improvement in surge protection over voltage protection for spacer cable or tree wire compared to bare wire.
Thank you. We had an attendee asking if you can expand on the voltage regulation advantages of spacer cable versus tree wire.
Super. Okay, so when I look at voltage drop, it's current times impedance, and that impedance is resistance plus inductance. Well, the resistance of a 336, double AC spacer cable and the resistance of a 336 ACSR or triple AC is going to be pretty darn similar, right? So there's no advantage there with the resistance. The inductance is going to have two values. It's going to have its intrinsic inductance, which I can't change, and then it's a mutual inductance. And the mutual inductance is, there's a formula for it. I won't tell you. It's proportional to the log of the GMD on GMR. So if I look at the geometric mean distance, which is the 1/3 root of a triple product of the interface spacings, when I bring those three phases closer together, I vastly reduce the geometric mean distance, and my mutual inductance or my total inductance goes by the logarithmic factor of that. So that's why when I bring the phases together, I cancel 15 to 20% of the impedance, and I have 15 to 20% less voltage drop. I have 15 to 20% improved voltage at the end of the feeder. And I'm banging around. I might use switch cap banks, but they're coming on and off less frequently. And I'm certainly going to have voltage tap changers on my transformers, but they're going to be banging around a whole lot less. And should that caller, it's good for engineers. We like to see formulas. And if that caller writes to me or writes to you, I will give them the formulas and a write-up on that subject.
Thank you. The next question is, does Hendrix recommend any insulation piercing shear bolt connectors?
That's two different questions. I don't know what we mean by shear bolt. Do we recommend IPCs? I have to say that insulation piercing connectors, they've got to be the best thing since sliced bread. I think they're one of the best inventions in modern times here. There's no stripping. We witnessed the type tests. We wrote a technical paper on this. I think they're going to remove a lot of objections with respect to how you're tapping, because some people don't want to strip and they don't want to cover up the strip. When you use an IPC, you're great. You don't need line duck on the messenger. You don't need an arrestor, and the system is always covered. It's fantastic.
What is the BIL of the covered conductors?
Okay. In terms of voltage magnitude, or what is the concept of BIL, basic impulse insulation level?
It did not the question did not specify.
Okay, well, BIL is basically how big, how intense a lightning bolt can hit that piece of equipment before it blows up or fails or pierces, if you will. The BIL, I can send you a BIL chart on our different phase conductors. BIL at 15 kV is between 2 and 250. The 25 kV, I forget, it's higher. 35 kV higher. I know it's 69 kV. The BIL is around 1,000 kV. But again, if you send me that in writing, I can send you something intelligent in writing with charts and graphs and what have you.
The next question, does Hendrix provide a shorter crossarm for tree wire systems, potentially a metal one or fiberglass type?
Yeah, good question. We don't supply crossarms. We know that some clients are using tree wire, and I've seen it. And just using, instead of the 9-foot crossarm, they use maybe a 4.5-foot crossarm because they're not worried about conductor clashing. We don't supply those crossarms.
Next question is, it was mentioned that spacer cable provides lower wind loads, but do messenger wire and spacers increase pole loading versus bare wire? They're wondering particularly about weight.
Yes. Spacer cable with the 3 covered conductors and the messenger, yes, it is going to increase pole loading, and therefore, we can help you evaluate the viability of whatever pole you're using for whatever NESC or CSA condition as a function of span length, NESC loading, Rule 250D. But the short answer is, usually you can use the same pole. In marginal cases, you must go up 1 class in pole sizing.
Next question, what is the maximum span possible in 69 kV construction?
I would say theoretically, there's no such thing as a maximum span. We are grappling with that. I would say so far, the largest span we've built at 69 kV with spacer cable has been relatively short, say 500 feet. I know that we've built spans over 2,000 feet at 15 kV. If I was building a 69 kV span and you said, I want a really long span, what I would do, we would have our engineering department model it in PLS CAD, and we'd have to take a look at the sag, right? So yeah, we can always build a long span. Theoretically, there's no limit, but at some point, the sag is going to do me in. So we can look at that. We can look at that modeling on a specific situation. If we're going from mountaintop to mountaintop, no problem. If we're doing crossing a bridge, if we're crossing a river, usually we have some extra clearance. If we're going just down the street, there are limitations because there's only so high the poles can go. And it would also be a function of conductor size, of course. So I sorry to throw that in at the last second.
And it looks like this will be our last question. So a big roadblock for many utilities when going to covered conductors is operations. Does Hendrix offer training for operations, specifically installation?
Absolutely, positively. So what we have now, we have a service department, and we have people that have spent 20, 30, 40 years installing spacer cable at utilities that have spacer cable. And then they come to Hendrix and we give them the most difficult jobs on planet Earth. I mean, we've done shockingly complicated jobs. We had covered some of those in webinars last year. But these linemen, installation specialists will go out, they will do pre-construction meetings with your linemen or your contractors, get everything set up so the day we construct, it's like the New York Philharmonic, everything goes in sequence. They can be there during the installation and Do we have line trucks and our own linemen to install? No, we don't. We did that in the past. It's a possibility that we'll get into it in the future. We were also doing turnkey jobs where we would go hire the contractor and then we do everything. I'm not sure if we're doing that at the moment. You would have to ask. I have Dave Shockley. You can ask Dave Shockley or Kristen Vanderwall if we're doing turnkey projects today. If you asked us to build a 500 megawatt wind farm, that would probably be out of our wheelhouse. But if you wanted to, build 10 spans down Main Street, I'm sure we could do that. But anyway, I hope that answered the question besides my babbling.
Yes. Thank you again, Brian. That does conclude today's webinar. Thank you again for everyone taking time to join us today. A brief survey will appear in your browser once you leave the webinar, and we would greatly appreciate your participation. We hope that you have a good rest of your day and that we can see you on future webinars. Thank you, everyone.